Okay, so this is like a Python session. Okay, so in Python, uh, first question it will be like how we need to install and what we need to install. So first, whoever don't know or never heard this name Anaconda, okay, so just search anaconda.com, okay, and from there install this Anaconda individual edition. Not right now, maybe after this session, okay, install it. Once you install, in your machine only, you can see there is something coming, Jupyter Notebook. Okay, once you click on that, this Jupyter Notebook, okay, Shamim is joining. So once you click on that, okay, what will happen? It will start a command prompt or terminal like this way. Okay, automatically it will start, and in your browser it will open something like this. It will open something like this in your browser. Okay, so here what you need to do, just see this i.ipynb. Okay, so this is the extension, okay, of this Jupyter Notebook. So Jupyter is basically look like, if I'm just opening, just see, it's look like a notebook only. Why? In notebook, this style we can actually mention. Now today, what you need to do, you need to know how these things are basically working, means how you can actually implement this one. Not only the code, along with that, this kind of text like a heading. If you are normally implementing a code, trust me, that is applicable for software engineering, that is applicable for as a QA. But for machine learning, for data science, your notebook should be so much commented or with some heading, image properly written, so that if you are sharing with someone as a PDF, that person can understand what was there. Maybe today, whatever the things we are going to learn, here it's not actually required, but from EDA, from the next session, your documentation, it's so much important. So in your assignment also, if you are writing only code, trust me, your assignment is failed. So documentation is also required. How? That we will see once we actually follow up with this thing. Okay. So what I did, it's open like this way. If you don't have any IPYNB file previously created, so just click on this. Okay. And click on like a text file or notebook icon, Python 3. So once I click on this, it will give me one notebook. Okay, it create one notebook like this way. And over there, I will write. So first thing today, what we are going to learn, that is numpy. So numpy is basically a package or library from Python. Okay. And whatever the thing we're going to learn, we will mainly focus on array, vector, these kind of things. Why? Because if, okay, just think like if there is any image, you know that image is constructed based on RGB, correct? Red, green, blue color, three colors are there. So each color is holding from 0 to in between of 255, correct? Now, if that particular pixel is representing three value, so that's basically an array of a pixel. So like this way, it's very much important whenever you are actually focusing on this array system. Now we will learn what is array, what is vector, what is scalar, how things are working. Now before that, let's start. Okay, so this is how I need to actually import numpy. You no need to install again, correct? Okay, like you no need to install separately this numpy library. This all included, this numpy, matplotlib, then panda we will also going to see. This all are included within this Anaconda what you just installed. Okay, so you no need to install separately. You need to just import it. Okay, and I'm giving alias name like np for numpy and plt plot for this matplotlib. Okay, so what is the difference? Now you can ask me, in Python also there is array. correct? So there is totally pointless to implement another library like numpy. The point why is so? So what I need to do, I will write like this way. I will click on run. So it's run actually. Now I'm writing again like numpy. This is meaningless. I no need to write again because I already hold that. So I will just run this one. See, this is my normal array. Okay, so this is my numpy array and this is my normal array. Okay. Now, what is this? A range. Okay, now this is very important. Before you do anything, just remember one thing. If you press double time D, that's mean you are deleting a particular cell. This is called cell. Okay. If you pressing double D, so if you are deleting. If you are pressing B or A, so that's mean you are inserting. So this is like a shortcut. If you are pressing Shift plus Tab, so that is for suggestion or help for particular. Like see, you don't know, correct? What is NP arrange? Correct. So for this, we will use Shift plus Tab so that we can see like what is the library function, what is the other parameters there. If you are pressing Tab at the running code, so this will help you to auto suggestion. You can do everything over there. Okay. Another part is there, that is Control plus Shift plus P. If you are using Mac, so it will be CMD. Okay, CMD plus Shift P. So if I try just doing like Control plus Shift P, see, this is a command group, whatever the command is there. Okay, so maybe it will be difficult for you for the time being at this point, but once you are used to with this one, so no issue. But here for your speed up only I'm doing. Now, just I'm pressing Shift Tab. See, I press Shift Tab. Now it's showing. This is the doc. A range. Okay, where is the start? Where is the stop? The step, and this type is basically none. Return evenly spaced value within a given interval. So I'm just creating a range, nothing else. I'm just creating a range, a simple range. Okay. So if I'm doing a simple range, okay, through numpy and a normal array like a list, so we can do both. Now, here is the difference. If I am running a timer, like to want to check like how much time it will actually taking to do this multiplication, okay, or do this multiplication, whatever. So this multiplication is basically for my normal list or array. This multiplication is doing on top of numpy. So just think, this code is so simple to write, but this code is little bit of problematic because you need to use for loop over here also. Now, how you need to write this part, don't worry about that. Just check blindly. Like this is so much less code. This is so much extra code is there. Okay. Now, if I'm running this code, see, numpy took 34 milliseconds to run this operation. And this normal list of the Python, it took 1.46 seconds. That's why numpy library is so fast, because their algorithm is totally optimized. Okay. Now let's come to multidimensional array. So normal array, you can define with the third bucket only. So this is same as you all know. Now this numpy array over here, if I want to generate some random data, okay, so simple. Numpy already have one function that's called random, and this RADN. Okay, again I'm pressing Shift Tab. Just see, return a sample for the standard normal distribution. Now see, the things are started. I told you guys, correct? Maths is so important. Now the first question is arise, like standard normal distribution. What is standard normal distribution? Okay, don't worry about that. Just think, set a total set in your mathematics, in your Venn diagram. Just think, a set is basically a standard normal distribution, a part of data that is sample. So it's taking that sample data only in between of 2 or 3. It's a range in between number 2 to 3. It will take the range. So how it's actually doing? So 2 and 3, basically I'm creating a multi-dimensional, correct? So again, you can think this is like a row, this is like a column. So row is like a this first row, and this is like a second column. Okay, and it's creating a some random value over there. Now after that, if I need to do some multiplication or like addition, we can do easily like this way, a normal simple normal way only. If I'm actually writing this way, so let's see, I am just deleting this one. So let's see what is the shape, only shape. See, shape is coming like 7 4. Shape means what is the dimension of that array. You all know, correct, array. So I'm just guessing you all know array. So one message came. Yeah, absolutely. That word I am actually not right now mentioning, because it will treat something else that I will come. Okay. So you know array, correct? In that array, just think if that array is basically two-dimensional array. Two-dimensional array means there is row, there is columns, correct? In three-dimensional, there is row, column, and another depth is there. Like if you treat like height with depth. Now just think that array we can define as a matrix as well. M into N matrix that we all know. So this is the thing we are basically just creating. Now creating a ND array. ND array means basically n dimensional array. So there is no limit. We can create n dimensional of array. But point is, why we require this kind of things, correct? Means why we are actually discussing this ND array and all, why we are learning. Think, if you are doing a single digit, so we can say this is a point, correct? So this is, we can say point is one only, nothing is there, only a single point. If we are creating m cross n array, so that's mean if I say like 2 cross 2 means row is 2, column is 2, that's mean 4 points are there, correct? This is 2D. Now if I'm saying 2 cross 2 cross 2, that's mean here is 6, correct? So not 6, 8. Now think, if I'm saying you dimension you need to create. In representation also, this point is a single point. This one is basically like a in 2D. Just think, suppose there is one point, here is one point. So if this is your x-axis, if this is your y-axis, correct? This is your origin, 0, 0. So in x-axis, maybe this is 2. Maybe in y-axis, this is 3. So the point of this point is basically 2, 3, correct? That we all know from basic geometry. Now think about 3D. Now, if there is one point, so again, it will come like this way. So here maybe this one 2, 3, 3. Now when I just create a 3D diagram, okay, now it's very difficult, correct, to project in a paper. Now think about only 4D. If I ask you to create a 4-dimensional, can you draw 4-dimensional? Can you visualize 4-dimensional? You can't, correct?
No.
You can't, correct? Because 4-dimensional is comes with space and time. Okay, if I ask you to 5D, 6D, then if you want to visualize this much of D, can you represent anything? Mathematically, yes, this is possible. That's why maths is important. Algorithmically, yes, this is possible, but you can't visualize. That's why this algorithm, this data structure is so much important. This linear algebra, what you are going to learn in the next session, that is so much important, because what you can't visualize, but you can compute. Okay, you can, you can do some dimensional reduction. Means if I want, I can deduct this dimension from here to 3D or 2D. I can deduct. So there are some technology or algorithms are there that is called PCA, PSNI. Okay, that we will learn. We will learn in our session, so that we can visualize this much of dimensional data in the form of 2D and 3D. So this is the flavor of linear algebra. Okay, so leave that part. Not going over there. So again, so all the codes are there, so you no need to worry. I will share. Just play around with those codes. Okay, I'm not discussing everything because that is totally useless. Now this is like a data type of array. If I need to create a float type array or integer type array, how we will create? Up to this is a normal array. When I define D type, means data type, and I'm giving like np.float64 in 32, it will actually treat first array as a float, second array as an integer. Okay, so just check these things. Don't, no issue over there, trust me, it will not going to hamper. Okay, now this is a very vital point. Okay, just 1 second. Yeah, so again I'm creating a range, okay, in between of 10, 0 to 10. So this is my range I created. Okay, now just think, I want to split or slice, I want to split or slice a array. How I will do that? You can see this 5 colon dot. So this is their positional value as an index. So 5 to 8, basically it's actually slicing these 3 values from this range. Can anyone tell me from 5 to 8 how?
Fifth position and the last means last after the last value. Means 8 put 5, 6, 7 and
Yep.
8. Like in JavaScript there is slice like that.
Yes, absolutely. Means it will start from the first value, that is 5, and the last value, before last value, it will split. Okay, so 5, 6, 7, these 3 value is 12, 12, 12. So we are slicing. Got my point? Now, if I need to add another value from that slice, in that slice, I assigned in a different variable, ARR underscore slice. So in that variable, first position, that is this one, I'm changing the value with this one. Correct? Now, if I am showing the full array, obviously it will replace. So now I am started playing with those vector. Okay, if I treat this is as a array or vector, yes, I started. Now, if I'm just giving like this way only, simple, only colon, there is no start and end limit, then what will happen? Whatever, because in ARR slice, I have 3 values, correct? So with this 64, all the 3 values will be going to replace. Previously, there was 12, 12, 12. I replace one value with 1, 2, 3, 4, 5. So it's showing. Now, if I'm not mentioning anything in this slice value, obviously it's replacing all the values with this one. Correct? So up to this is clear. This is very easy, but you need to understand. Now, this is like another form. Wait, no question. I told you, no question in the during session. Okay, now just think this array. Okay, this array having like, what kind of array? This one. This is a normal array, but it's having like 3 row, 3 column. Correct? this array, 3 row, 3 column, but its position on index 2, it's basically saying which one? 0, 1, 2. So this is, if this is the position, so obviously it will return 7, 8, 9. So I asked for this second position, is returning in the second position. Cool. I can call like this way also. See, like position, zeroth position in where we have 1, 2, 3, correct? Or 0, 1, 2. Now, in between of this one, in between of individual one, I have 0, 1, 2. So that's mean as a whole 0, 1, 2. So I called this one 0, means the first one, first singular array, this one. And I called 0, 1, 2, means this one. Correct? So it's returning me 3 because here is 3. Correct? So if you want to see, just think like this way. 1, 2, 3, 4, 5, 6, 7, 8, 9. Correct? So this is your 0 position, 1 position, 2 position, 0, 1 position, 2 position. Correct? In a matrix. So what is this point? So this point is basically nothing, 0, 2. Correct? So 0 from this side, 2, this side. So that's what I actually asked over there. And is returning in 3. See, this is the 3. Okay. The same thing it will happen if I am actually doing like 3D array also. I can do the same way. I'm not defining this is because it's the same thing. Okay. Indexing with the indexing and slicing that we just saw. This is another part only, but major thing is indexing with slice. Okay, so this one we already saw, but just think, if I'm writing like this way, one value is there in the end, but there is no value in the left. So that's mean from left at the beginning up to the second index, whatever the things are there, everything it will take. Everything it will take. How you will know? ARR 2D. Okay, let's go back to ARR 2D. Let's see how its ARR 2D look like. So this is my ARR 2D, correct? Correct. So I said blank colon 2 means this one 0 and 1 it will take. This 7, 8, 9 it will not take. See over here, it's took 1, 2, 3, 4, 5, 6, 7, 8, 9. It not took because I given over here 2. If I given over here 3, then what will happen? Let's run. See, everything is came. But if I'm just writing, don't worry about these values because in between of multiple things we did, so that's why values are changed. But the concept of basic slicing is like this way only. Okay, clear? Now we have like 3 values, correct? We have 3 values. If I want to split individual array with 2 value, not like 3 value, then we can define like this way with extra 1 parameter. I need only 2 and 3. See, Boolean indexing is very simple. Okay, again, so this is all type of indexing. Okay, don't worry, this is not like a huge thing. You are just defining an index, a simple index. Okay, so I'm just not actually doing over there because this is, again, this is important. See, transposing of array. See, this is all about the array. Transposing on array means you are, okay, let me define the transpose of array. If your array, if this is your array, this is your array, correct? What is that array? How many rows are there? Your row number is 5 and column number is 1. So this is called 5 cross 1 array, correct? Now, if you are doing transpose means we basically, if this is like a W, so we will delete like W transpose like this way. So it will look like, yes, like this way.
Yes.
And this is what? This is your 1 cross 5. So you are converting your row to column, column to row. So you are converting. So this is transpose. Okay. So how you can do that? Very simple. I am just reshaping. I am just creating a fast array range between 0 to 15, all the number. See, I never mention manually all the numbers over here. What I just did, I just create a range from 0 to 15 and just mentioning reshape that number from that sequential number 0 to 15, reshape that to 3 to 5. Means 3 what? 3 column, correct? 3 column and 5 rows. I'm saying if I'm not giving or not saying which vector, which array, by default it will be column vector or column array. Okay, so it's just created. Now if I'm transposing this one, see, okay, let me leave it this one. If I'm writing this one, see, this is coming, correct? Like this is 3 row 5 column, correct? This is 3 row 5 column. But if I am writing over here this line only, like ARR dot capital T, then what will happen? It's transposed, correct? So this is another part. You guys know, correct? Dot product that we will learn. We will learn in real algebra. If you don't know, that is perfectly okay. No issue. So this is like a multiplication with the dot product we are doing in between a normal array and transposed array, and it is returning some error, like some value output. Okay. So leave it that part. This part you guys will check whenever I will share. Now I move to panda. In panda, the same thing. Panda, a sequential structure, it's called a series. Over there it's array, numpy. Here it's called series. Okay, same. Everything is same. Nothing extra. Now see over there. I just created a series over there like a key value pair. Okay, that I can create easily. Okay. Now let's move to data frame. Tabular structure means that array. In our practical world, okay, whenever you will do in future, we will maximum time use panda, not numpy, because panda is much more advanced. Okay. So now just think we created a panda kind of frame. So this is called a data frame. Don't be confused. Over there is array. Here it's actually separated to series and data frame. Otherwise, everything is same. Now head means it will return the fast five head value. Okay, everything is same, so I am not touching over there. Now focused on this part. This is again important. If you have a CSV file that you need to import, because without data, obviously you can't do machine learning or data science, correct? So you need to import some data. So what I'm doing nothing. First I imported numpy and panda. I just wrote like pd.read CSV. So this is the function. And I'm collecting one CSV file and defining in a data frame. DF means data frame. So see, I just printed out DF. See, if I'm writing that read table, so this is like a table, then I need to mention separated symbol by which this CSV file is separated. If I'm not giving read table, if I'm giving only read CSV, it will be simple only, direct. Okay, so this is the, like, multiple technique how things are working. Now see how you are defining the header values of individual column that I'm defining manually. Okay, now see this message I passed in the front only. Okay, I am defining names. This is my names, and index column will start from message that I am defining. So it's moved, correct? Now I'm creating two index column. One is key, another one is key 2. In key 1 is basically the two values there, 1 and 2. Okay, and key 2 is basically all the values are there like previously. So I'm by manipulating with those data, loading those data and started manipulating. Okay, so this is how I can directly open a text file. So I can use that read.table file also like a text file, normal text file, not like from CSV. Okay, so this one Okay, I'm just keeping this part. This is the same thing with multiple variable. How you can create, you read that, correct? Now, if you want to create or write something in a text file or like a CSV, how you can do that? So this is the code. See, you need to just write. Okay, so this sys import sys is basically a system function of this Python library. Using this sys, you are basically calling two CSV function and you are writing stdio out. If you know Java, you already learned like standard output. We have like this standard output device. So we are using standard output device and using this pipeline, we are writing some file in our storage. Okay. So this is like working with delimited format. So delimited format that we already saw, that comma and all. Okay. So I'm not touching over there. You can deal with this JSON. Like maybe your API is returning some JSON value. You need to play with this JSON. Simple. Just write import JSON. That is already there in that Anaconda. Now you need to just write JSON that loads and you need to pass that object, what it's coming. And you got that. You got that total result. Now play whatever that you need to do, play with that result. You just convert it or dumps that data in another variable. And you see, I just shifted to a data frame from JSON to data frame in a tabular structure. Correct? Like based on what? Like siblings. Siblings. So this is my sibling. This is the object. And this is like nested object with these siblings. So using that, this name and age, I created a data frame. Simple. So this is now you can directly, if in your HTML page, if your HTML page is holding some bit of table, you can scrap those data directly. That's called web scraping, that you can do some web scraping directly with this read HTML. That is also part of Panda. So read JSON, read table, read HTML, read text, read CSV, read XLS, that we will come. So all this part. In fact, you can parse with this XML format also. Okay, so that is not required XML, so I'm leaving that part. See, this one is a binary format. So frame pickle, that we will learn when we will learn machine learning. We will learn pickle file. We will generate like a binary format to store our data. Okay, so that format also. HDF5 format. This is another file format for machine learning. So that format also you can actually store or read. Okay. See, Excel file, pd.excel file, you can easily read. Read Excel. You are reading that particular sheet from that Excel. Okay, that you can do. From web API using import request, you can directly call those data. Okay, whatever the data is coming, no matter, you can convert in a JSON format also. You can do it. MongoDB, MySQL, everyone having like some bit of driver. So you can directly play with those one also. Maybe you have some data that you need to play. You can directly play with those data. So this is the flavor of data loading through Panda. So now just think. First you learned numpy, that's the basic array transformation you are doing. Then you learn Panda, where you are playing with those series and data frame. You are converting those data, correct? So that you can calculate. Another part is there for Panda, that is what? You can read some file, because ultimately all those data you need to read either from database or you need to read from some file. Okay. So I'm stopping sharing. I have over here like 4 minutes. So let